In this video, I'd like to talk about the math question of the day for February 5th, 2023. And for this question, we're dealing with number systems once again, where we have to convert this number, which is an octal or base 8, to binary, which is base 2. And to understand this problem, to answer this, you need to have a deep understanding of number systems. So go ahead and pause the video, see if you can figure this out on your own. Spend at least a couple minutes thinking about this, and when you're ready, unpause the video and we can go through this together. Now at this point, I will assume that you have attempted the problem, so we can go through this together. And as always, if you have any suggestions for future videos, please go ahead and leave a comment below with that suggestion. So when dealing with number systems, we need to remember what each of these place values actually represent depending on the base. We're used to a base 10 system, but base 8 or base 2 or whatever base we want, they all work in a very similar way. Now, for a base 8 number system, keep in mind that there are only 8 digits that we can use. And for a base 2 system, there are only 2 digits that we can use. In fact, whatever the base is, in this case 8, we'll use every digit below that. So a base 10 number system, like we normally use, has 10 different digits, 0, 1, 2, all the way up to 9. So for this number, let me just rewrite it. We have 4,736, and let's just think about what each of these places actually represent. This is the ones place, or the 8 to the 0 place. This would be the 8 to the first power place. This is the 8 squared place, or the 64's place. And this is the 8 cubed place, or the 512 place. So if we wanted to convert this to base 10, we take the 4 and multiply it by its place value. So 4 multiplied by 8 cubed. Then we do 7 multiplied by its place value, which is 8 squared, or 64. Then we do 3 multiplied by 8 to the first, its place value. And then a 6, which is in the ones place, or the 8 to the 0 place. So in base 10, this number is 2,526. And again, this is the base here, base 10. We could even write a little 8 here to acknowledge that this number comes from base 8. And remember for base 10 that it works the same way with the place values, except instead of these powers of 8, these are going to be powers of 10. 10 to the 0, which is 1. This is 10 to the first, or that's the tens place. This is the hundreds place, or 10 squared. And this is our thousands place, or 10 to the third. So a base 2 number system would just have different powers of 2 for each of these place values. And for converting to a different base other than 10, I find it easier to think about this process as filling buckets. So we will write out many different place values for our base 2 number system. We can imagine each of these as a bucket, where this is the 2 to the 0 place, this is 2 to the first, 2 squared, 2 cubed, and so on. Let me write in all of those, and I'll also write in their numerical values in base 10. This is the 1's place, the 2's place, the 4's place, the 8's place, and so on. And after filling these in, it looks like we actually need more of these. So let me make a little bit more room so that we can fit it, and I might have to squeeze these extra place values in here. This would be 2 to the 9th, 2 to the 10th, 2 to the 11th, since we need to fill whatever the first bucket is with this number here, or something close to this, but smaller. And keep in mind, the general strategy we're using here is taking our number that's in a base other than 10, converting it first to base 10, and then from there converting it to base 2. There are likely other ways to approach this, but this is a fairly straightforward approach. It might be a little bit tedious going between 2 different bases, but it will give us an understanding of all 3 of these bases. So 2 to the ninth, that is the 512th place. This is the 1024th place. And this is the 2048th place. And that should be enough. So it looks like if we went one step further, let me just draw this in so that we have it, the 2 to the 12th place, that would be 4096th place in base 10, or using our normal number notation. This bucket right here would not be filled because our number is less than this. So we wouldn't fill that one, but we can fill this bucket. We can put 1 in there. And after that, we just need to think of how much we actually have left. So we can take our 2,526 and subtract off what we just put in this first bucket here, this 2,048. So in total, we would have 478 remaining. So we go to our next bucket, but we don't have enough to fill this, so we're going to put a 0 there. We don't have enough to fill this bucket either, so we would put a 0 there. But we do have enough to fill this bucket, so we're putting, out of what we have left, 256 into this bucket here. And once we subtract, we will take our 478, subtract 256, and we have 222 remaining. So we need to keep going. It looks like we can fill this next bucket here. We can put 1 in here, and we again just need to figure out how much we have left. So we take our 222 and subtract 128, so that now we have 94 remaining. And we go to our next bucket, which we can fill there. So we're putting 64 of these in here. So we have 94 minus 64, so now we have 30 left over. And that's not enough to fill this bucket, so we can put a 0 there. But we do have enough to fill this one. And so we take 16 out of that. And we know 30 minus 16, now we have 14 remaining, which means we can fill this bucket. That takes another 8 out, so we have 6 left. We can fill that, taking another 4 away, so we have 2 left. We can fill this one, and that is everything. So we don't have enough to fill this last bucket, so we put a 0 there. So all of this work to get this string of 1s and 0s, let me write this down. We have the number now that this, let me write it out, 4,736, which is in base 8, is equal to this 2,526, which is in base 10. And we just determined that in base 2, this is 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0. And again, this is base 2. And of course, if we do want to check this to make sure that this is in fact true, we can essentially just go in reverse and convert it back to base 10 and then convert that back to base 8. But converting this back to base 10, we essentially just look at which of the buckets are filled and multiply them by their place value and then add it all together. So we have 1 of this 2048, we have 1 of the 256, 1 of the 128, and so on, and we'll add those together. And when you do that, you will get back this 2,526, which we know is equal to 4736 in base 8.